Hello friends, welcome back to Relief Tutorials. Today we are going to learn laws of exponent, which we have already learned in 8th standard, even though we will discuss a few identities. So here identities I am going to discuss. First one, a raised to m into a raised to n. See here, this is called exponent, power, this is called base. So here base are same, powers are different. Base are same, powers are different. So a raised to m into a raised to n. So that is equals to a raised to m plus n. Have you got it? See, for example, I can say 2 cube into 2 raised to 5. Look here, base are same, powers are different. So what you have to write? You have to write the base 2 and you have to add the powers. When it is multiplication, you are adding the powers. So 2 raised to 3 plus 5. So that is equals to 2 raised to 8. Have you got it? So this is rule of product. Now second one, a raised to m upon a raised to n. Here you see quotient. Base are same, powers are different. So that is equals to a raised to m minus n. So when it is in division, you will get minus. When it is in product, you will get plus. Have you got it? See, for example, I can say here 2 raised to 5 upon 2 cube. Look here. Base are same, powers are different, so just you have to subtract the powers, that is 2 raised to 5 minus 3, that is equals to 2 square. Clear? Now third one, see a raised to m whole raised to n. Here you see this sign, this bracket indicates multiplication, the power will get multiplied. Excuse me, the power will get multiplied. So that is equals to a raised to m whole raised to n means a raised to m into n. Clear? Now fourth one, a raised to minus n. See, generally there is a tradition when we write any number in form of base and exponents, exponent should never be negative. A raised to minus n. So that will be 1 upon reciprocal of a raised to n. Just remove the minus sign and write in the form of reciprocal. For example, see if I say here, okay, 2 raised to minus 3. So I can write this is 2 raised to minus 3 means 1 upon 2 cube. So that is equals to 1 upon 8. So in both direction you have to remember a raised to minus n is 1 upon a raised to n, or 1 upon a raised to n is a raised to minus n. Okay. Now fifth one, anything raised to 0. Anything raised to 0 is always equals to 1. Example, say if I say 5 raised to 0, so that is equals to 1. Clear? Now sixth one, nth root of a raised to n. Very important identity this is. Nth root of a raised to n. So you have to remember here that, see, here m. So this will be a raised to, this is power. This is power, this is base, and this is root, nth root. So this power will be always in power. You can't remove the power of any person. So this power will be in power, and this fellow who is in this corner, okay, will remain here in corner itself. So mth root of a raised to n is a raised to n upon m. What you have to remember, here we are removing the root. See, root has gone. So here power will be in power, and whatever here this m, okay, in this corner will remain here in denominator. Clear? Example, see if I say, okay, square root of or cube root of 2 raised to 2 square. So this will be 2, this base 2 as it is. This power will be in power, upon this 3 will be here. Have you got it? So 2 raised to 2 by 3 means 2 raised to 2 and cube root. Clear? Have you got it? So this is the way you have to remember. Clear? Say example, if I say in this manner it is 4 raised to 3 by 2. So this 4 as it is. This 3 is in power, so here also in power, and this 2 here, that is square root. So square root of 4 cube. Clear? Square root of 4 cube. 4 raised to 3 by 2. So square root of 4 is 4 cube here. Okay. So this 4 as it is, this 3 will go in power, this 2 here. Have you got it? So this is the way you have to remember. Clear? 4 raised to 3 by 2. So if it is square root of 4 cube, so you will write 4. This cube will be in power and this 2 here. Have you got it? So in this way you have to remember the formulas. Or we can write in other form also. See this 4 raised to 1 by 2 and whole cube. Can I write this way? 4 raised to 1 by 2. See now a raised to m raised to n. This a raised to m raised to n. So you multiply both this thing m minus n. So here also you multiply 1 by 2 into 3 is 3 by 2. So what you will get here? Now you will write here this formula you will be applied. So what you will write 4. Here 1 is in power. See this 4 raised to 3 by 2. How you have written this in the same manner we will write 1 is in power. Okay, this will be here square root. Clear or not? Are you getting what I am telling? See 2 raised to 2 by 3 you have written this way. So this is square root. 4 raised to 1 and this is square root. So this will be here and 1 will be power. So 4 raised to 1 and square root of 4 is and this 3 will be here. This 3 is here as it is. Have you got it? So square root of 4 is 2. So that is 2 cube. 2 cube is equals to 8. Are you understanding what I am saying? Here I am implementing this identity. Here I am implementing this identity. Clear? So if it is 4 raised to 3 by 2. 4 raised to 3 by 2. So 4 raised to 3 by 2. So I have written 1 by 2 raised to 3. 4 raised to 1 by 2 means square root of 4. That is cube. That is 2 cube at 8. See anything raised to half. Anything raised to half. See now 16 raised to half. So 16 raised to half is nothing. Here what you will write here, this square root, this 2 will be here, this power will be power. 16 raised to 1. So no need of writing. So square root of 16. Square root of 16 is 4. So 16 raised to half is 4. Half means square root. Have you got it? Simply no, 16 raised to 1. So this is power. I told you, whatever here, this will be numerator and this will be denominator. See here, the cube root of 2 square. So how will write this 2? This power will be in power and this cube will be here. Clear? Similarly, I will write, see, 4 raised to half. So how will write, you know that this 4 raised to half means this power will be power and this will be here, square root 2. Okay, so 4 raised to half is nothing but square root of 4. X raised to half now. X raised to half is nothing but square root of x. Have you got it? These things. So this is one identity. Now 7th. A raised to m into b raised to m. See here. Both are different identity. Here base were same, powers were different. Here powers are same, base are different. So A has power m, B also has power m, A and B both have same power, so I can write here AB raised to m. Clear? 8th one. Now see. A raised to m upon B raised to m. These two are different identities. A raised to m upon A raised to n, A raised to m minus n. Base should be same, then this identity is. Here you see powers are same, base are different. So I can write this A upon B whole raised to m. Why? Because this m is power for A as well as for B. Clear? So these are the identities. I hope you understood these identities. Clear? Everything clear? So go through this. And one more identity I will explain here. 9th one. A upon B raised to minus n. So I can write this way. B upon A, reciprocal. This reciprocal. This is a rational number, ratio. A upon B raised to minus m means B upon A raised to m. Okay, why? Because you can solve this, you can derive this by using all this identity. This identity A raised to minus n is 1 upon A raised to n. So A upon B raised to minus m means how you will write? 1 upon A upon B raised to m. You take this as x raised to minus n. So x raised to minus n, 1 upon A raised to n. So this you can write this way, 1 upon A upon B raised to m. Clear? So that is equals to 1 upon a raised to m upon b raised to m. So now this will be b raised to m upon a raised to m. Clear? 1 upon reciprocal. So that is equals to b upon a raised to m. So a upon b raised to minus m is equals to b upon a raised to m. So directly you will remember this identity. Okay, no need of solving this. Have you got it? So a upon b raised to minus m is b upon a raised to m. I hope you understood all this identity. Please go through all this identity. Very important page. Now we'll do exercise. Last exercise of our textbook. Clear? It is the last and final exercise. We are going to complete our chapter. Exercise 1.6 textbook. Exercise 1.6 textbook. Clear? See here. Textbook first one. 1. Find 64 raised to half. So this you can do in many ways. I have the formula. If you know 64 raised to half means square root. See, I told you. X raised to half means square root of x. Now 64 raised to half means square root of 64. Clear? Square root of 64 is 8. Have you got it? Or in other manner also you can see the 64 and here 2. So it is square of which number? So I can say 8 square. 8 square is 64 raised to half. In this manner also you can do 2 cancel. Now you know this formula here. A raised to m whole raised to n is equal to a raised to m into n. This is multiplication. Bracket means multiplication. You will multiply both this power. So you will multiply both this power means 8 raised to 2 into 1 by 2. 2 cancel. That is equals to 8. Answer is 8. Okay. Have you got it? Or you can do in another manner also. I told you 64 raised to half. So that is equals to, you will write here, no, this square root. This will go here and 64 raised to 1. 64 raised to 1 is 64. Square root of 64 is 8. Got it? Any way you can do. Second one. 32 raised to 1 by 5. See, look here, base 5. So can you write this number in a power of 5? Yes, 32 means 2 raised to 5 is 32. So I can write 2 raised to 5 whole raised to 1 by 5. Now you will multiply those two. So 5 will get cancelled. Answer is 2. Have you got it? Third. Now 125 raised to 1 by 3. See, look at this base 3. Can you write this number in a power of 3? Yes, 5 cube is 125. So I can write 5 cube raised to 1 by 3. This 3 cancels. So answer will be 5. Have you got it? Simple. Now question number 2. First one. Find 9 raised to 3 by 2. So here I can write this way if you know 9 raised to 3 by 2. So how you will write here? You know that 9 cube and here square root. In this manner also you can write. But you have to solve this. Square root of 9 cube. So it will be a little bit difficult. So what we will do here, this is 9 and you have to write here in denominator 2. So you have to write in a power of 2. So can I write here 3 square? 9 is 3 square raised to 3 by 2. So now you will multiply both this identity. So you will multiply both this to 2 to cancel. What you will get? 3 cube and 3 cube is equals to what? 27. Simple. Second one. 32 raised to 2 by 5. Nothing. 32 you have to write in power of 5. Here we have done. See, 32 in power of 5. So 32 in power of 5 means 2 raised to 5 raised to 2 by 5. Now you will multiply both these two. 5 will get cancelled. So you will get 2 square. 2 square is nothing but it is 4. Simple. Now third one. 16 raised to 3 by 4. So what you have to look here, you have to see the denominator 4. So this number you have to write in the power of 4. So this number you write in a power of 4 means 2 raised to 4 raised to 3 by 4. So this 4 will be cancelled. So 2 cube, remaining 2 cube. 2 cube is nothing but it is 8. Got it? Now fourth one, see. 125 raised to minus 1 by 3. 125 raised to minus 1 by 3 means you know the formula here. See, what you will write? A raised to minus n is 1 upon a raised to n. Clear? Remember this identity. So 125 raised to minus 1 by 3, a raised to minus n. This way, a raised to minus n is 1 upon a raised to n. Just write the reciprocal and remove this minus sign. That's all. So 25 raised to minus 1 by 3 means 1 upon 125 raised to 1 by 3. Clear? This way you can write. Now that is 1 upon 125 and here is 3. So you can write 5 cube raised to 1 by 3. So this 3 will get cancelled. So answer will be 1 upon 5. Clear? So I have completed here question number 2. Now question number 3. Question number 3. Simplify. Simplify here 2 raised to 2 by 3 into 2 raised to 1 by 5. Question number 1. See, a raised to m into, this dot means product, multiplication. A raised to m into a raised to n. So what you will write? A raised to m plus n. So you will add the power. So 2 raised to 2 by 3 plus 1 by 5. So that is equals to 2 raised to, here LCM. 5 and 3 LCM means 15. 15. So 3 5s are, 5 2s are 10. Plus 5 3s are, 3 1s are 3. So that is equals to 2 raised to 13 by 15. So this is our answer. Which identity we have used here? A raised to m into a raised to n. Now second one. 1 by 3 cube raised to 7. So many ways you can 1 upon a raised to n. So you know that here a raised to minus n is 1 upon a raised to n. So 1 upon a raised to n is a raised to minus n. So 1 upon 3 cube means you can write 3 raised to minus 3. Clear? See here 1 upon a raised to n. So here we have 1 upon 3 cube. So that will be written as 3 raised to minus 3. Here there will be minus sign. That's all. See here. Raised to 7. So a raised to m whole raised to n. So 3 raised to minus 3 into 7 minus 21. Okay, 3 raised to minus 21 is our answer. Third one. 11 raised to half upon 11 raised to 1 by 4. So base are same, powers are different. A raised to m upon a raised to n. You know this, a raised to m upon a raised to n. So answer will be a raised to m minus n. Base are same, then you have to subtract the power. So that is equals to 11 raised to 1 by 2 minus 1 by 4. So that is equals to 11 raised to LCM. LCM is here 4. So 2 2s are 4. So here you will get 2 minus 1. So 11 raised to 2 minus 1, 1 by 4. 11 raised to 1 by 4. Clear? Now fourth one. What is fourth one? 7 raised to half into 8 raised to half. See here we can't use the identity this a raised to m into a raised to n. We can't use this identity. Why? Because here base should be same. But here base are different. But powers are same. So what you will write here? 7 into 8 raised to half. See this identity. I told you here. This identity. Powers are same, base are different, multiplication. So you will multiply the base and you will keep same power. So multiply the base, same power. 7 8s are 56. 56 raised to half. This is our answer. Have you got it? So with this we have completed your exercise. But we are going to do few extra problems. Okay. Why? Because this exercise is quite small in your textbook. So we are going to do some extra problem. Okay. So extras. Extra sum. So we are going to do some extra sum. Okay, see. I will write the question. 1. See here, find value of 16 raised to half whole raised to half. 16 raised to half whole raised to half. So now 16 raised to half whole raised to half. You should know that 16 raised to half means root 16. Clear? Okay, never mind. A raised to m whole raised to n. So I can write here 16 raised to a raised to m into a raised to n. This identity a raised to m whole raised to n. So a raised to m into n. So half into half. So half into half. So that is equals to 16 raised to 1 by 4. Now here 4. So you will write this 16 as 2 raised to 4. And whole raised to 1 by 4. 4 cancel. Answer will be 2. Got it? Now question number 2. Simplify the expression. See this. 81 raised to minus half. Clear? Raised to minus 1 by 4 raised to 2. So this we have to simplify. So very simple. See, now a raised to m whole raised to n. This is base. A raised to m whole raised to n and raised to this. So you have to multiply all these three power. This identity. A raised to m whole raised to n is equal to a raised to m into n. Same thing you can write. A raised to m whole raised to n raised to p. Means nothing. First you will multiply these two identities. So you will get mn. Then you will multiply this identity p. So a raised to m into n into p. Same thing we can say here. So how we can do this? See, 81 raised to minus half raised to 1 by 4 and raised to square. So this can be written as 81 raised to minus half into minus 1 by 4 into 2. Clear? So this 2 will get cancelled. Minus into minus plus. So what you will get here? 81 raised to 1 by 4. 81 raised to 1 by 4. Now 4. So can you write this 81 in the power of 4? Yes, 3 raised to 4. So I can write here 3 raised to 4 whole raised to 1 by 4. So this 4 cancel. Answer will be 3. So 3 is our answer. So don't get confused by seeing a big problem. Process is very easy. Clear? So now third one. See, you want to evaluate 4th root of 12 into 7th root of 6. This you have to evaluate. So how will you do? This 12 raised to power is 1 by 4. But here 12 cannot be written in the power of 4. So what you will do here? Just you have to evaluate this. See here. So you have to do in a very simple form. You can't solve this. You can't find 4th root of 12. So you will find the prime factor of 12 and prime factor of 6. So prime factor of 12, you know that 2, 6, 2, 3, 3. So this you can write as, see 12, first I will convert this, 12. So you know this identity, see. This identity, you know, mth root of a raised to n upon m. So we are using this idea, 12 raised to 1 by 4. So what you will write here, 12 raised to 1 by 4 into 6 raised to 1 by 7. So now 12 raised to 1 by 4, see, not base are same, not powers are same, nothing. So we will find the factors of 12. So 12, 2 into 3 raised to 1 by 4 into 2 into 3 raised to 1 by 7. So now you know what do you mean by this. So this power is 4, 2 and 3. So I can write here 2 raised to 1 by 4, 2 raised to 1 by 4 into 2 raised to 1 by 4 into 3 raised to 1 by 4 into 2 raised to 1 by 7 into 3 raised to 1 by 7. So now 2, 2, 2. So a raised to m into a raised to n into this. So you can write here 2 raised to 1 by 4 plus 1 by 4 plus 1 by 7 into. Have you got it, friends? What I have done, I have used the identity a raised to m into a raised to n. So a raised to m plus n. When base are same and in product you have to add the powers. Here see x raised to m into x raised to n. So x raised to m plus n. So I will write 3 raised to 1 upon 4 plus 1 upon 7. Have you got it? So now you will add this. So 2 raised to, you will find the LCM. 4, 4, 7. So what will be the LCM here you want to find out? So 1 plus 4, we can write this way 2 raised to 1/4 plus 1/4, 2 raised to half plus 1 by 7 into 3 raised to 1 by 4 plus 1 by 7. Now you will find the LCM 7 and 2. So LCM will be 14. Clear? 14 is LCM. Now how many times 2 sevens are? So you will write here 7 plus here 2 into 3 raised to. Here also LCM 7 and 4. So 7 and 4 LCM will be 28. How much it will be? 28. So here how will you write 28? 4 sevens are. So 7 plus 7, 4. So 2 raised to 7 plus 2, 9 upon 14 into 3 raised to 7 plus 4, 11 upon 28. Clear? So we got here 2 raised to 9 upon 14 into 3 raised to 11 upon 28. Clear? So this is our answer, or if you want to write in the form of root. Why? Because problem is in form of root. So you can write this also in the form of root. So now you know the identity. A raised to n by m. So that is equals to what you will write here? This power will be always in power. So a raised to n, and this here denominator will be here. This identity we have used. So here same thing you have to write. Now what will write? 14th root of 2 raised to 9 into, now here you know this 3, power is 11, and here you will write 28. Have you got it? So this is our answer. You can further simplify if you want to simplify it. Here 14, here 28. If you want to make power same, you have to multiply if you know that both. See here, 9 upon 14 is multiply numerator by 2, denominator also by 2. In that fashion you do if you want to do. See here. Why? Because here it is 28. Here it is 14, 9. So you multiply both numerator and denominator by 2. Okay, see I will cut this. You will multiply both this numerator and denominator by 2. So what you will get here, see. See what you will get here, this is your formula. So what you will get here, 2 raised to multiply by 2, this and also this. So 9 2s are 18 upon 28 into 3 raised to 11 upon 28. Now what you will write this in this power? So that will be equal to square root of 2 raised to 18 and here 28 into here also 3 raised to 11 and 28. So root is same. Root is same. So final answer will be, this will be 28 root of 2 raised to 18 into 3 raised to 11. Why? Both root 28, root 28. So I have written root 28 and I have taken in that. This is your answer. So in this way you can simplify. Okay, some extra problem. Don't get bothered about this problem. Try to simplify. Now we'll do few more problems. See, problem number Fourth. See here, problem number 4. Simplify. You have to simplify. See, simplify root 25 upon cube root of 64 plus 256 raised to, plus 256 upon 625 raised to minus 1 by 4 plus 1 upon 64 125 raised to 2 by 3. See, this we have to simplify. Clear? So very simple. See how we'll do this. Root 25. So you know root 25 is 5. I can write cube root of 64. So 64. So you can write here this 64 raised to, you know the identity. See, identity we are using nth root of a raised to n. So that is a raised to n upon m. So here what is cube? And power is 1. So 64 1 upon 3 plus. Now see here power, this identity a upon b raised to minus m is equals to b upon a raised to m. So we can write 625 upon 256 raised to 1 by 4 plus. Clear? Now here 1 upon 64 upon 125 raised to 2 by 3. So 1 upon a raised to n. So 1 upon a raised to n, you know 1 upon a raised to n is equal to a raised to minus n. Okay, so what you will write here again, 64 upon 125 raised to minus 2 by 3. So you can write the 1 upon a raised to n, say identity, 1 upon a raised to n here, this identity, a raised to minus n. So 64 upon 125 raised to minus 2 by 3. Again, you can change this directly. See, 5 upon 64 means you want to write in the power of 3. In the power of 3 means 4 cube is 64. So 4 cube raised to 1 by 3 plus here 1 by 4. 625 and 256. So this 625 is 5 raised to 4. 256. 256 is 4 raised to 4. So 5 raised to 4 upon 4 raised to 4. 5 raised to 4 upon 4 raised to 4 raised to 1 by 4 plus. Here I can write 125 upon 64 raised to 2 by 3, this minus. This identity. A upon b raised to minus m is equals to b upon a raised to m. So this 3 will cancel. So 5 upon 4 plus. Here you see this. 5 upon 4 raised to. This I can write a raised to m upon b raised to m. So I can write 5 upon 4 raised to 4 and whole raised to 1 by 4. Plus same thing here. 125 means 5 cube. 64 means 4 cube. So 5 upon 4 the whole cube raised to 2 by 3. Have you got it? Why? Because this is 5 cube, this is 4 cube. So 5 upon 4 the whole cube. Now your identity, if you know that. Which identity? A raised to m whole raised to n. So a raised to m into n. You will multiply both this power. 4 will get cancelled. 5 upon 4 plus here 4 will get cancelled. 5 upon 4 plus here 3 will get cancelled. So 5 upon 4 the whole square you will get here. 5 upon 4 the whole square. Okay. Now nothing we have to do here. 5 upon 4 plus 5 upon 4 plus 5 square 25. 4 square 4 4s are 16. Clear? Now just LCM. So what will be the LCM here? 4 and 4 are the factor of 16. So here 16 will be the LCM. 4 4s are 5 into 4, 20. Plus here same 20 plus here 25. So what you will get here? 65 upon 16 is our answer. Got it, friends? Nothing, just few formula we have applied here. That's all. Clear? Directly from this we can use this step if you know that. 1 upon a raised to n. So a raised to minus n. A raised to minus n. In order to remove minus reciprocal. So directly 125 upon 64 raised to 2 by 3. Directly you can write. Clear? So this is the case. Fourth one we have done. See, many such problems are there. But we have limited time. So I will do few importance problem only for you. See, one more extra. This was fourth. Now problem number 5. See, if 125 raised to x is equals to 25 upon 5 raised to x. Find value of x. Find value of x. So I will do here, see here. 125 raised to x is equals to 25 upon 5 raised to x. This is our problem. Okay. So this 25 I can write 5 square. This 125 I can write 5 cube. So I can write here 5 cube, the whole raised to x is equals to, this is 5 square upon 5 raised to x. So now a raised to m whole raised to n. So I can write 5 raised to 3x is equals to. Now a raised to m upon a raised to n. So 5 raised to 2 minus x. Have you got it? Identity which we have used here. A raised to m upon a raised to n is equals to a raised to m minus n. This identity I have used here. Now you see here. In here you can come to know that base are same. Base are same and they are equal. So base are same and values are equal means power also will be same. If base are same, power are same. If power are same, base are same. Okay, remember that. See, if I say here 5 raised to x is equals to 5 raised to y. So base are same. So this implies x is equals to y. Have you got it? So I can say 3x is equals to 2 minus x. This x will be here. Minus x comes here. So 4x is equals to 2. So x is equals to 2 upon 4. So x is equals to 1 by 2. So the value of x is half. Got it? Now same thing we can do one more problem here. See. Problem number 6. If 6 upon 5 raised to x into 5 upon 6 raised to 2x is equals to 125 upon 216. Find x. You have to find x. Okay, so what is given here? See, 6 upon 5 raised to x, 5 upon 6 raised to 2x is equals to 125 upon 216. See, 125. 5 cube, 216, that is 6 cube, 5 cube, 6 cube. Now here see 6 upon 5, here 5 upon 6. So the reciprocal, see reciprocal of 6 upon 5 is 5 upon x. So 6 upon 5x, so I can write this way, 6 upon 5x is equals to 5 upon 6 minus x. I told you the identity, see here. A upon b raised to minus m is equals to b upon a raised to m. So if b upon a raised to m, so that will be a upon b raised to minus m. See, b upon a, reciprocal of b upon a is a upon b. Here it is plus, then here it is minus. If a upon b, reciprocal of a upon b is b upon a, here minus, so here plus. Okay, so that way I have used 6 upon 5. So reciprocal of 6 upon 5 is 5 upon 6 and here plus, so here minus. So now both the reciprocal has become, both base has become same. See, 5 upon 6, 5 upon 6. Have you got it? And you should note, 125 is 5 cube, 216 is 6 cube. So 5 upon 6 the whole cube. Now a raised to m into a raised to n. Identity, if you know that. A raised to m, base are same. A raised to m into a raised to n. A raised to m plus n. So 5 upon 6 raised to minus x plus 2x. minus x plus 2x. So that is equals to 5 upon 6 the whole cube. Now 2x minus x. So 5 upon 6 raised to x is equals to 5 upon 6 the whole cube. Now base are same. Base are same, both are equal, so power are also same. So therefore you can say x is equals to 3. So both are same type of problem. Clear? Okay, so this is 5th. Now we'll do problem number 7. Problem number 7. What is that? See here. X raised to a minus b whole raised to a plus b into x raised to b minus c whole raised to b plus c into x raised to c minus a whole raised to c plus a is equals to 1. So you have to show that. Show. So we'll take LHS. See LHS. Now x raised to a minus b whole raised to a plus b into x raised to b minus c whole raised to b plus c into x raised to c minus a whole raised to c plus a. So we have used one identity. If you know a raised to m whole raised to n or a raised to m into n. So x raised to a minus b into a plus b. You look here, a minus b into a plus b. So a minus b into a plus b, you know what is a minus b? One identity we have, a minus b into a plus b, algebraic identity, a square minus b square. Difference of two perfect squares. So here we can write x raised to a minus b into a plus b means a square minus b square into x raised to b square minus c square into x raised to c square minus a square. So now a raised to m into a raised to n, base are same. See, all base are same here. Base are same, a raised to m into a raised to n. So a raised to m plus n. So you will add the power. You will add the power. So x raised to a square minus b square plus b square minus c square plus c square minus a square. So a square minus a square cancel, minus b square plus b square minus c square plus c square. So x raised to 0 and x raised to 0 is equals to 1. That is equals to RHS. Got it, friends? So this type of problems are there. Clear? So I hope you will do this type of problem. One more problem I will do. See. Question number 8. Evaluate 2 raised to 40 plus 2 raised to 39 plus 2 raised to 38 upon 2 raised to 41 plus 2 raised to 40 minus 2 raised to 39. See, this you have to evaluate. Now see, 2 raised to 40 plus 2 raised to 39 plus 2 raised to 38 upon 2 raised to 41 plus 2 raised to 40 minus 2 raised to 39. Now it is difficult to find 2 raised to 40. 2 raised to 40 means 2 into 2 into 2 into 2 into 40 times, 39 times. So it is quite difficult, but you look at these three terms. So from this you can take common. Which power is smaller? 38 is smaller. So I can take here 2 raised to 38 as a common. So if 2 raised to 38 as a common you will take. So here what will be left? 2 square will be left. Why? Because 38 plus 2, 40. Now see, a raised to m into a raised to n, a raised to m plus n. So 38 plus 2 you will get 40. Plus, now 2 raised to 38 you have taken common. Here 39. So 2 raised to 1. Plus, here 2 raised to 38 you have taken already common. So what is left here? 1 is left. Got it? Same thing here. 2 raised to 41, 2 raised to 40, 2 raised to 39. So I will take here 2 raised to 39 common. So 2 raised to 49. So 2 square. 39 plus 2, 41. Plus 2 raised to 1, minus 1. Got it, friends? Okay, now see. A raised to m upon a raised to n. So you can write a raised to m minus n. So you can write here 2 raised to 38 minus 39. And 2 square, this see, you have 2 square, 4. 4 plus 2 plus 4 plus 2 plus 1 upon 4 plus 2 minus 1. So what you will get here? 2 raised to 38 minus 39 means 2 raised to minus 1. And here 4 plus 2, 6 plus 1 7 upon 4 plus 2 6, 6 minus 1 5. Now a raised to minus n, you know a raised to minus n 1 upon a raised to n. So 2 raised to minus 1 means 1 upon 2 raised to 1 into 7 by 5. So 1 into 7, 7. 2 into 5, 10. So answer is 7 by 10. So value of this is 7 by 10. Got it, friends? So there are some other problems, but I am going to do the last problem. See here of your chapter. This is very important. Very important this is. Now question number 10. See, this is if 2 raised to x is equals to 3 raised to y is equals to 6 raised to z, then prove 1 upon x plus 1 upon y minus 1 upon z is equals to 0. This you have to prove. Or you can say z is equals to xy upon x plus y. Anything. See now, this you have to prove. Very important problem this. Okay. See how we'll do this. Now let 2 raised to x is equals to 3 raised to y is equals to 6 raised to z is equals to k. We'll suppose the value. 2 raised to x we don't know what is the value of x. It may be 5. So 2 raised to 5 equal to 32. And they are equal. So let it be equal to k. So now we can say 2 raised to x is equals to k. 3 raised to y is also equals to k. And 6 raised to z is equals to k. Clear? Now you have to remove this x. See here. See friend. 2 raised to x is equals to k. So what you will do, see how you have to remove, I have to remove this x. So in order to remove this, what you have to do, you have to multiply the power by 1 by x. Here also same thing, the power of k is 1. So you will multiply this power by 1 by x and this power also by 1 by x. So this x will get cancelled. So 2 is equals to k raised to 1 into 1, 1 by x. So if 2 raised to x is equals to k, then 2 is equals to k raised to 1 by x. See, this is the thing. Have you got it, friends? 2 raised to x is equals to k raised to 1. I want the value of 2. So I have to remove this x. In order to remove this x, I have to multiply by 1 by x. So here also power 1 has to be multiplied by 1 by x. This cancels. So 2. And here k raised to 1 into 1 by x. 1 by x. So moral of the story is that, see here, look here at this 2 step. If 2 raised to x is equals to k, then 2 is equals to k raised to 1 by x. Have you got it? So here also I can write now 2 raised to x is equals to k. So therefore 2 is equals to k raised to 1 by x. 3 is equals to k raised to 1 by y. And 6 is equals to k raised to 1 by z. Sir, why you have find out the value of 2? But see here 6. 6 is nothing but it is product of 2 and 3. Are you getting? 2 into 3 is 6. That's why. So I find out 2 and 3 and this is 6. Clear? So now 6 is equals to k raised to 1 by z. But 2 into 3. So I can write here, see 6 is equals to k raised to 1 by z now. But 6 is equals to 2 into 3 is equals to k raised to 1 by z. I can write now 2. See 2, this is 1. Now 2 is equals to k raised to 1 by x. So in place of 2 I write k raised to 1 by x into, in place of 3 I will write k raised to 1 by y. So that is equals to k raised to 1 by z. Got it? So now a raised to m into a raised to n. So k raised to 1 by x plus 1 by y is equals to k raised to 1 by z. A raised to m into a raised to n. A raised to m plus n. Identity. Got it? Now see here. Base are same. Both are equal. So powers are also same. So I can say here 1 by x plus 1 by y is equals to 1 by z. Have you got it? So now 1 by x plus 1 by y equal to 1 by z. So I can write now this 1 by x plus 1 by y. This here. So minus 1 by z is equals to 0. So we got proof here. Have you got it? So we have proved this. So this is proved. 1 by x plus 1 by y minus 1 by z. See, 1 by x plus 1 by y minus 1 by z equal to 0. But we have to prove this also. So also we know that here 1 by x plus 1 by y is equals to 1 by z. We have this. We have this, see, 1 by x plus 1 by y is equals to 1 by z. So now 1 by x plus 1 by y equal to 1 by z. So I will take LCM. LCM is xy. Now x cancels. We will get y. Here y cancel. Here we will get x is equals to 1 by z. Clear? Now you want z equal to xy upon 1 plus. So I will do inverted if you know that. Or you multiply here. Cross multiplication. So you will get z into x plus y. Can I write is equals to xy. Cross multiplication. Now what you have to find out value of z. So z is equals to xy upon x plus y. I want z multiplication. So this will go in denominator. So we have proved this second identity also. Nothing this. We have proved z is equals to xy upon x plus y. Nothing, just taking LCM. That's all. You will get that. So with this we have completed our chapter. I hope you have enjoyed this extra problem. So please keep on practicing. Thank you very much.